All right, good morning, everybody. Just a couple of quick announcements to get started. If you haven't done assignment 1 yet, there are 2 small mistakes on assignment 1. So in the Python module that I gave you, in the function called numcells, that return statement's missing. So when you go to translate that into Java, the Java compiler will complain you're missing a return statement in your function, in your method. So that you have to add that return 0 there. And then finally, the second announcement regarding the assignment, there's a typo in the assignment document. I tell you to use a method called toDeepString to print the array. It's actually deep2string to print the array. But I think anybody who's done the assignment, you would have caught that by now, because the compiler would have told you and suggested the correction for it. Thank you to the student who brought that to my attention yesterday. Also, your quiz dates are set. Actually, I think those were always the tentative quiz. Those were always the, oh no, sorry. I never actually told you what the quiz dates are. Those have been set. So those will be on the Wednesday in Chernoff, because the tables in Chernoff are a lot nicer than the ones in here. So we'll write in there on the Wednesday, February 8th, and then March 15th. Right, those will be pen and paper, pencil and paper, whatever you want. You'll just write your answers in the answer booklet, but it is handwritten as opposed to doing it on the computer. And that's it. Anybody have any questions about the assignment? All right. The second assignment should come out later this week, hopefully Thursday. So as soon as the assignment 1 is due. All right. Today's lecture is about creating and using objects. All right, so it is possible to write a Java program using only primitive values, right? So it's technically possible to write a very, very complicated program using only ints, booleans, and doubles, or whatever floats. So when I say it's possible, but it's unpleasant. Almost any non-trivial Java program will make use of what are called objects, right? And the objects interact with one another. The reason we use objects in an object-oriented programming language is because objects can perform more operations than primitive values, right? So when you make a class, you're basically creating your own type, right? When someone makes objects of your type, they're able to use objects using whatever methods you wrote into your class, right? And you can obviously provide many, many more methods than you can do operations with, say, an int, for example. So whoever creates the class is able to provide as many methods as they deem necessary. And then whoever's using the class is able to use those methods. Right, so remember, objects contain information. Right? So where do you store information in any computer program? Well, you store them in variables. Right? So in an object, those variables are called fields. So that's the term I'm going to use. Other languages call them attributes. Sometimes in Java, you'll see them called instance variables. They all mean the same thing. They're variables that belong to an object. So they're just variables. So they can have whatever type you want, right? So they can be primitive types, and they can be reference types. Right? So what does that mean? It means you can make an object. That object is made up of other objects, right? Those objects are made up of other objects, and so on, and so on, and so on, and so on. Right? So it's possible to create very complicated very complicated object structures. Okay, what we call the state of an object is just the value of all of its fields. Right? So I'll give you an example of that in a little bit. Right? So the set of values of an object's field we call the state. Objects are able to perform actions. Right? So for example, sorry. Are you standing for a reason? I just.
Oh yeah, I lost my headphones.
Oh, okay. Sorry. Yeah, for sure.
I don't want to interrupt.
That's okay.
Sorry.
I was just wondering why you were standing there the whole time. Any luck? Okay,
Sorry.
it's all right.
Thank you.
Okay, objects can perform actions. So the methods belonging to an object define what actions the object can perform. Right? And so if you have two objects, they can talk to one another, right? They can ask each other to do something, right? And the way they ask each other to do something is they just call methods on the other object. So the object lifecycle looks as follows, right? So to use an object, you have to make an object, right? So you have to create an object. Then, of course, once you've created the object, you can use it. And then when you're done with the object, that object has to be destroyed because that object is eating up resources, right? It's occupying memory. It may have other computing resources that it's holding up or holding onto, right? So that object has to be destroyed so that the resources can be returned back to the Java virtual machine. In Java, the programmer has to create the object. They can use the object, but the programmer does not explicitly destroy the object. Right? And so in other words, you don't have to worry about cleaning up after your objects, which you do have to worry about in a language like C, which causes all sorts of problems. Right? So, objects are created using the new operator. So when you want to make an object, you're almost always calling new. Now sometimes, well not sometimes, many times you can call a method, and the method will return an object. But inside that method, there's almost certainly a call to new, right? Or that method causes new to be called. So the new operator does three things. Right? So it allocates memory for your object. Right? So however much memory your object requires, new will allocate memory for that. New is always paired with a constructor call. So a constructor is this thing that initializes the state of the object. And the new returns a reference to the new object. Right? So when you write something, when you make an array and you write, say, something like new int 10, right, you're calling the new operator. Right? The reason you can assign a value, the reason you can assign something to the array is because new returns a reference to the newly created array. Oops, sorry. Okay, so there's this point2 class that we're going to look at in the lectures. Right? They're also in the notebooks. So if you go in the notebooks, there's several different versions. Sorry, not in the notebooks. If you look at the source code belonging to the course, there's several different versions of the point2 class. Right? The several different versions are, so there's a different version for when you start, and then we add stuff to it. There's a second version, and we add more stuff to it. There's another version, and so on and so on. So if you import, that's not complete. Import ca blah, 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 dot point2, then you can use the point2 class in your code. All right, so this is an example of using new. Right? So we have point2, so it's a reference type, has a capital letter here. Right? There's new. There's a constructor call. And the constructor call looks a lot like calling a method. So every constructor, the name of a constructor is equal to the name of the class or the type. Right? So my class is called point2. So inside that class point2, all of the constructors are called big P point2. Right? And that constructor there, that creates a point2 object whose coordinates are 0 and 0. So a point2 object is just a two-dimensional point. So it has an x and a y coordinate, and they're both double values. Right? So we say that the state of this point2 object would be 0, 0. Right? Its x coordinate is 0, and its y coordinate is 0. Right? When we actually look inside the class, you'll see that there's a variable called x and there's a variable called y. The second line here makes a second point2 object, this time calling a different constructor. Right? Still a constructor call, right? Still the name of the class. This time you pass in two values. Right? So 1 and 0.5, and that makes a point whose coordinates are 1 and 0.5. Right? And finally, there's a third constructor call here. This time we pass in a reference to another point. Right? So that's a reference to point2 back here. And this constructor copies the object that P2 is referring to. Right? So the point that P2 is referring to is the one whose coordinates are 1 and 0.5. So that constructor there makes a new point and then sets the coordinates to the same coordinates as the other point. Right? So that right there is called a copy constructor. The first one is called the no argument constructor because you pass in no arguments. right? The second type doesn't have any particular name. It's just called a constructor. This is another example using a different class, right? So this is the scanner class that comes as part of the standard library, right? So import java util.scanner. Scanner is an object that can parse or read, so it can parse input and give you back, parts of that input. So for example, if you want to read the keyboard in Java, the typical way you do it is you make a scanner object and you tell it to scan system.in. So system.in is just a standard input, which is hooked up to your keyboard on a desktop computer. Right? So that scanner can read input from your keyboard. You could also scan a string. So here, we make a scanner, we pass in a string object, a string reference, and that scanner can process the string, one fish, two fish, red fish, blue fish, and extract parts of that string. Right? So for example, you can ask for the 1, then you can ask for the fish, then you can ask for the 2, then you can ask for the fish, and so on and so on and so forth. When you use new, it's always followed by a constructor call, right? So it's always new, constructor, or if you're making an array, it's always new, the element type of the array. So when you call a constructor, it looks like a method call, right? So back here, right, that sort of looks like a method call, right? You're calling a method named scanner, and you're passing in some data, right? But the language specification is very clear on this. It says constructors are not methods, right? So it looks like a method, not actually a method. One of the reasons it's not a method is because a constructor never returns a value, right? Not even void. And so you'll see when we start to write our own constructors, they sort of look like methods, but the return type is always missing. Okay, so where do you put your constructors? You put them in the class that you're creating, right? So every class, every class will have at least one constructor, right? And the constructors go inside the body of the class, right? Constructor names always must match the name of the class. If you don't match the name of the class, then it's not a constructor anymore. The compiler will think it's a method. Right? Why do we use constructors, or what should constructors always do? Constructors are supposed to initialize the state of a newly created object. Right? So in other words, when you make a point2 object, the constructor should set the coordinates of the point to some reasonable values. Right? You shouldn't just get back a random point. All right, so there's one of the common constructor types is called the no argument constructor. Right? So the no argument constructor is called the no argument constructor because the caller supplies no arguments. Right? In other words, the constructor has no parameter. Right? So the purpose of this constructor is to initialize the newly created object to some well-defined default state where the creator of the class decides what is the default state. Right? So when you go to make your own class, if you put in a no argument constructor, right, one of the decisions you have to make is, well, what should I set the fields to? Right? You do not have to put a no argument constructor in a class. If you're using a class, there may not be a no argument constructor. Right? Point2 has one, right? And so the point2 no argument constructor, it always sets the point. It always sets the state of the newly created point to 0 and 0. Right? So it's just the origin. I really should fix this. You need the .point2 here. You can't import a package. The copy constructor is a constructor that has exactly one input. The type of the input, or the argument, right, is always the same as the name of the class. Right? So the type of this argument here is always point2. Right? The purpose of a copy constructor is to initialize a new object by copying an existing object. Not every class defines a no argument constructor, right? So you don't have to put one into your own class, and any class that you're using may not define one, right? You have to look at the documentation to to determine if there is one or not, right? So this this copy constructor here copies the point p2, right? And so we end up with a new point whose coordinates are the same as p2. Right now they're independent points, right? So p2 and p3, they are independent. So if you somehow change the coordinates of P3, P2 doesn't change. Right? If you change the coordinates of P2, P3 doesn't change. Right? So you do get a new point, It's independent of the other point. And then a class can add as many constructors as it wants, subject to certain rules. So the point2 class also defines a third constructor that takes in a double and a double, right? And that constructor, the purpose of that constructor is to initialize the point so that its coordinates are equal to the passed-in values. Right? Scanner, so we saw the scanner example a few slides ago. It's got many constructors as well, if you actually look at the documentation. Right? So here's one where you can initialize a scanner to read the keyboard. There's a second one here where you can initialize a scanner so that it scans or processes the contents of a string. Okay, so once you've got your object, you can use it. How do you use it? You just call methods on it. Right? So once an object is created, you have a reference to the object. Right? Remember, you never get the object itself in Java. You always get references to objects. Right? And there is no way for the programmer to get to an object directly in Java. Right? You always have to access an object via a reference. To use an object, normally what happens is you take your reference. You take your reference, right? Dot, and then some method name, and then call the method with the necessary arguments. Right? If the object has a field that you can access, then it would be reference name dot, and then the name of the field, and then you can use the field. Right? So math has a field called capital PI, right? Math.pi, which represents the value of pi. And so you can access the field pi in the math class in a similar way. Oh, right there. So that's how you use a field name. Okay, so here's an example of using methods on point2. Right? So we make a point2 object. Its state is 0.5 and 0.1, right? So its x coordinates 0.5, y coordinates 0.1. Right? Point2 has a method called x, no arguments. Right? This returns the x coordinate of the point. Right? So the x coordinate of that point is 0.5. Right? Similarly, y returns the y coordinate of the point, so that's 0.1. Right? Using our x and y variables, we can change them. Right? So I can add 0.1 and subtract 0.1 from x and y. And then I can change the coordinates of p. Right? So by calling this method called x, this time this method has an argument, right? Takes in a double. So this version of x changes the coordinate of p to that value right there. Right? And this version of y changes the coordinate of p to that value right there. Right? So after calling those two methods, the coordinates of p are 0.6 and 0. Right? And then finally, there's another method called set. And set lets you change both values, both x and y values at the same time. Right? So after calling set here, well, the coordinates are still 0.6 and 0.1 and 0. Sorry. Right? And there's actually lots and lots and lots of other methods in the point2 class. But we're actually going to implement the point2 class during the lectures. So we'll see the other methods and how you implement them. Okay. So here's a little program that makes a point2 object and then moves it around on the screen. So we make a point2 object. Its coordinates are 0.5 and 0.5. Why did I write that in here? 0.2. I don't know why that line's there. It's probably, anyway, it's fine. So here we've got this variable called radius. Right? Its value is going to be 0.1. So this is going to draw a circle of radius 0.1 on the screen, and then it's going to move the point back and forth. Right? I'm using this class called standard draw, which is not part of the standard library despite the name. It's actually a class that was developed at Princeton University for teaching Java. What was in assignment 1, so in assignment 2, you're going to finish the implementation of the game of life. We're going to use the standard draw class again to draw the game of life. So that there's an animated GIF in assignment 1 that shows the game of life evolving over time. That's created using standard draw. So it's just an easy way to draw stuff on the screen. I think I have this handy somewhere. So let's just see if I can run this. Hopefully it's here. Sorry. Is it bounce? I think it's bounce. Yeah, it's here. So you can just copy and paste that into your, you can copy that code, create a class, stick it somewhere in the CISC124 source code, and then you can run it. So when you run it, you get the ball moving back and forth on the screen. Right? And there's a slightly more elaborate example under in the same package. So in the package CA Queens U CS CISC124 notes basics geometry that does a bouncing ball. Same idea. It's a little more complicated. I'm not going to go through the source code right now, but that one makes a ball that just bounces around. So if you're taking your first year physics course, this is just following the equations for a simple projectile motion, and it just does this forever. Right. Points are so two-dimensional points are they useful? So they're useful if you're drawing two-dimensional stuff or if you're trying to represent geometry in 2D. Right? Obviously, in your video games, most video games these days are three-dimensional, but it's a similar thing. Right? You have a three-dimensional point. It has an x, a y, and a z coordinate, and you can move stuff around. Right? So it doesn't take very much to go from this two-dimensional point class to something somewhat more interesting. Right? So it looks like a simple class, but it turns out you can use it for lots of interesting stuff. Here's an example of using the scanner class. I normally don't show students this because I never ask you to write a program that reads the keyboard, so that asks the user for input, and then you type stuff into the keyboard. Most of the software you use these days, you don't run the software that way, right? It all goes through a graphical user interface or something more sophisticated. But it's still common when we teach students how to program. So if you want to know how to read the keyboard, this is one way you can do it. Right? You make a scanner. Right? You pass in system.in to tell it you want to read the keyboard. Right? And then scanner has these methods, has several methods. One of them is has next line. One of them is next line. There's also like a next int, a next double, a next float, and so on and so on and so forth. Right? If you hook it up to the keyboard, then the method has next line. I'm pretty sure always returns true. Right? So this basically runs forever. Right? So has next line is just asking the scanner, is there more input available? Right? If it's hooked up to the keyboard, then yeah, there's potentially more input to read. I don't know if you can, well, I'm not sure if this always returns true or if you can actually stop it somehow. Next line returns the string that was typed in, that the user typed in after, so if the user types in a string and presses enter, next line returns that string. Right? And so this program here just loops forever and lets the user type some stuff in, they press enter, it echoes it back to the screen. Right? If you want the user to be able to quit in a sensible way, right, you have to look at what the user typed in. Right? So same code. This time we check, right? If the line they typed in equals the string quit, then you can break out of this loop, right? And then the program will end. Right? If you run this program, I think you have to type in Control-C, or there's a little red dot in a little red square in Eclipse when you run something. So I'm going to run this program again. Right here, there's that little red square that looks like the stop button on an old cassette player. If you press that, that will stop the program. Why it's down there and not up there, I don't know, but that's where it is. Right. Okay, so how do you find out what methods are in a class? Right? And so Java is nice because it was one of the, so I'm going to say it's the first major programming language that made it easy to actually find the documentation. Right? And so in other words, when the Java language was created, they made the decision that documentation shall be online. It'll have a standard format. There's a standard way to write it. And so all Java documentation looks the exact same way. Right? So you can find the documentation for all of the standard library classes in a convenient location. Right? You just Google Java, whatever version you're interested in, and then the name of the class. And it almost always pops up as one of the first few links. I'm just going to click on that link. So this is the documentation for version 8 of the language. So over here, so if you follow that link, you end up in this page here. Over here, it lists all of the classes in the standard language, right? There's a lot of them, right? Like thousands, right? So you don't want to look for your classes there. Don't scroll through that list there and try to find things, right? It'll take you forever. Sorry, I have to shrink this back down again because I'm missing something. Oh no, sorry, never mind, we're fine. Okay, so normally what you want to do is you want to look for what's called the package in which the class you're interested in is located in. Right, so packages are Java's way of organizing its classes in a sensible sort of way. Most of the packages we use in the class, they're either in java.lang or they're going to be in java.util down here. Right, so one of those two places. Let's look at java.lang. So if you go to java.lang, over here you'll see these things called interfaces. We haven't talked about those yet, but we'll get around to that in a few weeks. Your classes are down here, right? And so here you can see the classes. Some of these classes will be familiar to you, right? There's a double. Sorry, let me make this bigger. Right? There's double right there. Integers right there. Right? Where's string? String is right here. Right? So if you click on string, that takes you to the string documentation. Right? Up here, you'll see, right? That's the name of the package that the class is in. Oops, sorry, I didn't want to do that. This information here is useful, but it doesn't mean anything to us right now. Right? That tells you the inheritance hierarchy that the class is in. And we'll talk about that in several weeks. Also here, there's stuff, again, this is stuff that doesn't make sense to most, that won't make sense to anybody new to Java, right? But this tells you what interfaces the class provides. Again, we'll talk about that in a few weeks. And then there will be a section up here that describes what is the purpose of the class. Right? For string, right, it actually goes on for a fair, well, not too long. It's not too bad. Right? But there's a lot of, there is some detail here that is useful for the programmer to know. This one's a bit unusual. It actually has an example of how to use the string class. You don't always get that. Right? And if you keep on going, right, if the class has fields that you can access, they'll be here. And you can see the description of the fields. Constructors are here. Right? If you click on one, it'll actually jump down and give you the detailed description for each thing. Finally, the methods, if you keep on scrolling, right, you'll find the method summary. Now, when you look at the method summary, it tells you what is the return type. Right? It tells you what are the arguments, gives you the method name. Right? And if you click on it, it jumps down to the detailed description of what the method does. Right? So now you can see the entire signature of the method right there. Right? So when you look at that, you know it's public, so anybody can use this method. Right? Returns a car. Right? Takes in an integer index. Right? Detailed description of the method right there. So you read what the description says. Right? Whoops, sorry. Returns the car value at the specified index, and index ranges from 0 to length minus 1. It describes what are the arguments to the method. Right? So what is the purpose of the parameter index? Well, it's the index of the car value that you're looking for. Right? Tells you what it returns. Right? Tells you what what exceptions the method may throw. Right? And this is the same for all of the methods and all of the constructors in the class for every class. Right? And so if you look for the documentation for the, right? So the documentation exists for all of the classes in the course notes. Right? The reason they exist is because all of the classes are documented. So let me just go to point 2. So when you actually go and look at the point 2 class, you'll see that in front of the class, there's a comment, right? And it's a specially formatted comment. Similarly, for every method or constructor, there's a comment as well. And the comment has a particular structure, right? So it's got a description right here, right? It's got this funny, what's called a tag, right? So at param, there's one for x, there's one for y, right? So that's the documentation for those two parameters there, right? Let me go to a method, so something that actually returns a value. if a method returns a value, there's a funny tag that says @return and tells you what the return value is for the method. Right, so these things here are called Java comments, and that's the Java's language. That's the standard way that you document a class. Right, there's a tool called JavaDoc that will go into your class, read the comments, and then produce the web page containing your documentation. And I'll show you how to, we'll show you how to actually write JavaDoc comments probably next week, maybe this week, but probably next week. Right. Oh, okay. What time do we have here? 9 o'clock. All right, so if you're following along on the lecture slides, we are now on, I think, 7. No, 8. All right, so lists. Java lists are I guess they're the analog of a Python list. But the way you use them is very different. Well, the syntax and how you use it is very different. They behave similarly. Right? So they provide similar functionality to lists in Python. Right? The syntax, unfortunately, is very different. Right? So the syntax for Python lists is closer to Java arrays. Right? If you actually want a list, then the syntax is quite different. Now, in Java, you're allowed to choose from potentially many different kinds of lists. Right? Whereas in Python, normally you just make a list and you don't actually worry about what type of list it is. Right? So in Java, there's 2 main kinds of lists. And normally you only actually use one of them. So there's this thing called ArrayList, which is the class that you normally use. Right? If you click on that link there, that'll take you to the documentation for the ArrayList class. All right, so there's one of the big differences between a Java list and a Python list is that a Java list almost always holds elements of a single type. Right? Whereas in Python, you know that you can put whatever type you want into any list. Right? Now the problem is in Python, when you start to take stuff out of the list, you have to know what the type of the object is in order to use it properly. Right? And so Java says, look, your list shall only have the elements should only have one type. Because you know what the type is, it becomes easier to use the elements in the list. Right? The syntax is funny. So the element type goes inside of this less than and greater than. Right? So these brackets, these angled brackets. Right? Now you don't do this for every class that you use in Java. Right? You only do this for what are called generic classes. And list or array list is one of these generic classes. Okay, so here's an example of making a list of strings. Right? So the type is ArrayList. Right? I want the list to hold some strings. So inside the angled brackets goes the type, so string. Now it's just a variable. Right? So give it whatever name you want. I'm calling it T. Right? Use the new operator. Call the constructor. Right? Constructor name, right, matches class name. Right? So new array list, round bracket, and that makes an empty list. Right? So a list of size 0, nothing in it. Right? Now, if you do this for a little while, this starts to get old really fast. Right? So it gets really annoying having to type in array list, angled bracket, string all the time. Right? So after a few iterations of this, of having a few iterations of the language where you had to do this, they decided that on the right-hand side, you don't have to type in that name anymore. Right? So you can just write new array list, angled bracket, and away you go. Right? And the compiler will figure out what is the type, what is the element type of this array list. Right? Because it can just look on the left-hand side to get that type. So that's the way that you should make an empty array list. All right, so there's another limitation in Java's generic type mechanism. So that is, you can't make a list where the elements have primitive type, which is actually kind of annoying. So for example, I can't make an array list of int, right? Because int is primitive. Right? And so the way that they got around this problem was that they created a class that corresponds to every primitive type. Right? So for little b Boolean, there's a corresponding type, big B Boolean. Right? Now when you want a Boolean, you should use little b Boolean. Right? You should avoid using the wrapper classes when you can. because the wrapper classes are much slower than their corresponding primitive counterparts. Right? But if you want to use any of the generic classes, you have to use the wrapper types. Right? So for int, right, the corresponding wrapper class is integer. Right? For car, it's big C character. For double, it's big D double. Right? Why some of the names don't match their corresponding primitive type, I don't know. Right? Like I don't know why they didn't call capital character just capital car instead. But that's the decision that was made. Okay, so what do these wrapper classes do? Well, so the problem is they added, the Java language added this generic type mechanism in version, what version of the language now? 5, version 5 of the language. And so it was added quite late into the language. When they added this mechanism, the only way, they had a couple of choices on how to do it. One of the choices would let you make generic types where you could hold primitive values. The other way to do it, which is this way, which is the way they chose, you can't create generic types of, where the type is primitive. The reason they went this route is because it doesn't break any existing code. Right? So all the old code that used to work with the old array list class still works. Right? But now you have this inconvenience where if you want a list of int, you have to make a list of integer. So they tried to make it as easy as possible to use. Right? So the wrapper classes get special treatment by the compiler. And so the compiler will try to convert back and forth between a wrapper type and its corresponding primitive type automatically. Right? So here I've got int I, and its value is 1. Right? Now here I've got an integer object, j. Right? Now normally you wouldn't be able to assign a primitive value to a reference type. Right? But the compiler will will convert that I for you automatically. Right? So in other words, when the compiler sees that that's an int, and it sees that j is an integer, right, the compiler automatically converts that int to a big I integer object. Right? So that's called auto boxing. Right? Similarly, you can go the other way around. Right? So if I have a if I have a big I integer object, and I want to store its value in a primitive int, right, then the compiler will convert the reference type to a primitive type for you automatically. Right? So in other words, it'll go into that integer object, get its value, and then take the value and store that in K. Right? So that's called auto unboxing. Right? And so you can almost seamlessly interchange the two. Right? However, if you want an int, use int. Don't use integer. Right? It's way slower to use an integer than it is to use an int. All right, so if you want a list of some primitive type, you end up making a list using the wrapper type instead. Right? So if I want a list of int, you have to make a list of integer. Right? If you want a list of double, you have to make a list of big D double. If you want a list of car, you have to make a list of big C character instead. Right? So you can almost always pretend that your list of the wrapper type really just contains a bunch of primitive types. Right? So in other words, you can just pretend that array list of integer really is an array list of int. Right? So for example, I can add the value 100 to the end of the list. Right? So the add method adds to the end of the list. That 100, that's an int. Right? Its type is int. It's not big integer. But the compiler will take care of that for you. Right? It takes the 100, wraps it up in an integer object, and then adds that to the list. Right? Similarly, if I get a value out of the list, right, so get is the method where you access an element in the list. Right? You use an index, so there's one element in the list, so I can use index 0. Right? So if I get an element out of the list, well, it's actually a big I integer object, but you can store that in an int value because the compiler will convert it for you automatically. There's only one situation where this doesn't work that I know of. Right? And so there's a method called remove. So if you make a list of integer and you call remove and pass in an int, right? So remove, there's two versions of remove, that's the problem. One version of remove looks in the list for an element whose value is 100 and then removes the first element that's equal to 100, right? So that looks like what the programmer is trying to do here, right? It turns out there's a second version of remove. So the second version of remove removes by an index, right? So this one actually, because that type there is an int, this version of remove is actually the one that removes by index. So that removes the 101st element from the list. So you have to be very careful in this one situation. Otherwise, everything is seamless. Like you just pretend it's a list of primitive elements. Okay, if you actually want to remove the first object equal to 100, you need to make an integer object whose value is 100. Right? So somehow you have to make an integer object whose value is 100 and then ask it to remove the integer object. Right. Okay, so everything you can, not everything. Most of the things that you can do with a Python list, you can do with a Java list. Right? So if you're any good with Python lists, all you have to do is take what you would write in Python and convert it to Java. Right? Do I give you the Python here? No, I don't give you the, oh, here it is. Okay. What's the best way to do this? Okay. Let me just take a quick look. All right. So I want to make a new empty list. Right? So there you use the no argument constructor. Right? Array list string t equals new array list. Right? Nothing inside the round brackets. So that makes an empty list. Right? So in Python, when you would just write t equals square bracket, right? In Java, you would call the no argument constructor to make an empty list. Right? Is the list empty? Right? So there's an isEmpty method that returns true if the list is empty, false otherwise. Right? But in Python, you can just write if t, right? And that will tell you if the list is empty. Right? In Java, you have to write if t is empty. Right? How about the length of the list? So the length of the list is how many elements are in the list. Right? In Python, it's len. Right? In Java, it's .size. Right? It's not .length. Right? It's .size in Java. Right? In string, it's .length. In everything else, it's always .size. All right, I want to add an element to the end of the list. Right? So in Python, that's append. You might know some other way to add an element to the end of the list. Right? In Java, it's add. Right? You want to get an element from the list. Right? In Python, you use square brackets and an integer, possibly negative integer index. Right? In Java, you use the get method to get an element. Right? Indexes in Java are never negative. Right? They're always between 0 and the size of the list minus 1. Right? If you want to assign an element in a list, right, you can just do that, use the square brackets in Python. In Java, you have to use set. Right? So instead of t0, it's t set 0. And then on the right-hand side in Python, you'd write the value that you want to set the element to. In Java, you pass it in as the second parameter. Right? When you use set, you have to remember that there has to be an element at index 0 already. Right? So you can't take an empty list and then set the element at index 0 to something. That doesn't work in Java. Right? So set replaces an element at an existing element at the specified index. Right? So in other words, the element has to be there to begin with. Okay, if val in t, so that searches the list t in Python for a particular value, right? It returns true if val is in the list. In Java, the method is called contains. Right? If you want to join two lists together, right? In Python, it's extend. Right? So t extend another list takes the contents of another list and adds them to the end of t. Right? In Java, you use add all. If you want to remove an element by index, in Python, the method is pop. Right? In Java, it's remove. Right? Now, in Python, if you want to remove an element by value, so in other words, if I want to search the list for an element equal to that and then remove it, right? In Java, the method is also called remove, but you pass in the element that you want to remove. And finally, there's sublist here. Right? So in Python, you can get a sublist using the square brackets and slicing. In Java, the method is called sublist. Right? Sub, uppercase L. start, stop, right? So the indexes work the exact same way in Java as they do in Python, as long as you use non-negative indexes. Is there more? Yeah, there's more. To copy a list in Python, sorry, you can use the copy method, and that makes what's called a shallow copy of the list, right? In Java, you call the constructor, right? So I want to make a new copy, or I want to make a new list that holds the same references as T. Right? So in Java, you you make a new list by calling the by using new, calling a constructor, passing in the list that you want to copy, okay? And that copies a list for you. The other way to do this is to make an empty list, and then write a loop, and then add the elements of the other list to the new list, right? Or you can use add all, but the constructor is easier. If you want to count how many times an element appears in a list in Python, you can use the count method. In Java, there is no method in the list or array list types. So you have to find some other class that can count for you. So it turns out there's this class called collections in Java. And collections contains a bunch of static methods that operate on lists and things called sets. Right? So there's a frequency method. That counts the number of times the string ABC appears in T. Right? If you want to reverse a list in Python, it's just the reverse method. In Java, you have to ask the collections class to do it for you. Right? And if you want to sort a list in Python, you can either do t.sort. Well, let's do t.sort here. Right? So that takes the list T, sorts the contents of the list. Right? In Java, it's collections.sort T, or in anything past version 8 or 9, I don't remember what. You can write t.sort null, and that will also sort a list. Right? This one is, I forget which version of the language this one showed up in. Anyway, either way works. Right? They both end up doing the same thing. So this class collections turns out to be pretty useful when you're working with lists. So there are some methods in there that are worth looking at. Right? Hit that link there and take a look at the methods that are there. All right, so that's enough for today. So we'll look at some more. We'll look at examples of using a list in the next lecture.